Solve the inequality. Describe the solution set as an inequality in interval notation and in a graph. With the inequality that we have here, we can see that we have some fractions, and those tend to kind of make us a little bit nervous usually at the beginning, but we've learned some strategies for dealing with equations that have fractions in them, so we're going to use those same strategies for working with an inequality that has fractions. So remember, the first thing that we want to think about doing is clearing the denominators, and we clear the denominators by finding the lowest common denominator for all the fractions in this inequality. So I'm going to come over here and I'm going to write down LCD equals. And so remember, the lowest common denominator, the LCD, will be the smallest number that all of these denominators will go into evenly. And this one is sort of nice because the 12 goes into 12, 6 goes into 12, and 4 also goes into 12. So we can say that the LCD is going to be 12. And now what we're going to do is we're going to multiply every fraction here by the lowest common denominator. In essence, what we're doing is we're multiplying the left side of the inequality by 12, and we're going to multiply the right side of the inequality by 12 as well. And so that's going to involve some distribution here. And I'm actually going to show that distribution step because it gets a little bit messy with fractions. So I'm actually going to write that out. So my first part of my distribution, I'm going to have 12 times 3/4. So that's the first part. And then that's going to be plus. And then the 12 is going to also distribute through to that 5/6 x. So let's get that in there. There's my 5/6 x. And that's supposed to be greater than, and then notice that the 12 is going to get multiplied. Now be careful on your signs. Remember that this guy up here was a negative 7/12, so we want to be sure that we put that negative in there, negative 7/12. Now the beauty of this is where things are going to simplify out for us. Our denominators are going to cancel out. Each one of these 12s I can write as 12 over 1 because that's going to help me with the multiplication. And notice that we can do some what's called cross canceling here. So with 12 and 4, we know that 12 can be written as 4 times 3. That's the same thing as 12. And here the 4's are going to cancel out, just leaving me with 3 times 3, which would give me 9. Now plus is just going to come on down. This plus sign right here is just coming right on down here. And now when we do the simplifying on this next one, we have to think of 12 factoring in a different way. Here we're going to think of 12 factoring as 6 times 2, because again, we want to be able to cancel out the denominator. So those 6's are going to cancel out, leaving me with 2 times 5x, which is going to give me 10x. Now remember, we have an inequality here, so we want to be sure that we bring down that greater than sign here. And now we're going to cancel out in here. The 12s exactly match up. We don't have to worry about factoring anything out. We can just cancel those 12s out. Each of those are going to leave us with a 1. And 1 times negative 7 is just negative 7. Okay, now our inequality looks much better. Now we can start dealing with this a little bit. So remember, we're solving for x. So we want to move this 9 over to the right-hand side, and then we're going to divide out the 10 in the last thing. Gratefully, in this problem, we only have one x term, so we don't have to be worrying about bringing x's together. So let's go ahead and subtract 9 from both sides. Watch your signs over here on the right side. When we do the negative 7 minus 9, again, think about money. If you're in the hole and then you go more in the hole, you're just deeper in. So that's going to be negative 16. We want to keep our greater than sign, and we bring down that 10x. Because remember, the 9 and the negative 9 cancel each other out. Now to get the x all by itself, we're going to divide by 10. We're going to divide by 10. We need to do that on both sides of the inequality to keep things balanced. Here my 10's are going to cancel out and I'm left with x. Now be careful here. You might be tempted to change the direction of the inequality because you see this negative sign here. But remember, the rule is that we only change the inequality if we divide by a negative. We're dividing by positive 10. And so that means the inequality is not going to change directions. Now, with this particular problem here, this is a fraction that's going to need simplifying. And because the problem gave us fractions, we should give our answer as a fraction as well. It's true this would be an okay decimal to work with, but we're going to work with it as a fraction because the problem came to us with fractions, so we want to give our answer as a fraction instead of mixing fractions and decimals. So a negative divided by a positive is certainly going to give us a negative. So let's get that there. Now, to simplify this fraction, we want to be thinking about what's the greatest common factor. What's the largest number that goes into 16 and also goes into 10? I think we could agree that the answer to that is 2, because 2 times 8 is 16, and 2 times 5 is 10. So when we cancel out those 2's, that would leave us with 8/5. So our final answer is negative 8/5. So that's what we have as an inequality. But remember, we still need to come up with a graph, and we also need to come up with interval notation. Now, to create our graph, we have to figure out where negative 8/5 might be located on our graph. And so we certainly know that it's going to be to the left of 0. And so I could go ahead and put my 0 down. But negative 8/5, where the heck is that? Well, let's change negative 8/5 to a mixed number. That might help us to figure out where that's going to be located on the number line a little bit better. So x is greater than, so I'm still going to have a negative. And then 5 goes into 8 one time, and we have 3 left over. So negative 8/5 is the same thing as negative 1 and 3/5. So that's going to be somewhere between negative 1 and negative 2. So if negative 1 is here and negative 2 is here, that negative 8/5 is going to be in between those two, and it's going to be slightly closer to negative 2, because this mixed number tells us we go to negative 1. And then if we think about there being 5 little divisions here, 1, 2, 3, 4, 5, if we thought about that broken up into 5 equal parts, we would want 3 of those 5 parts between negative 1 and negative 2. So I'm going to say right about there would be my negative 8/5. So I'm going to label that out on my number line. Now we can go ahead and create our graph. So we know we're looking for the x's that are greater than negative 8/5. It doesn't have an or equal to, so we're going to use the open circle. And we're looking for the greater than. Notice that my arrow is pointing to the right. So that means I'm going to be going to the right on my number line as well. So there would be my graph for our solution set. The last thing we need to do is to come up with our interval. And we can see on the left part, we go down to negative 8/5 on the left side. And if you had used negative 1 and 3/5, that would also be okay. So negative 8/5 on the left. How far do we go to the right? Well, we go forever to the right. So that's where we use that infinity symbol. With infinity, we always use the parentheses. And in this case with negative 8/5, because we did not have the or equal to, negative 8/5 is not included as part of my solution. So we're going to use the parenthesis for the left side of the interval. And so there's our solutions to the problem.